Hello and welcome back to another Algebra 1 video. Today we'll be continuing lesson 3.4 with an extension on compound inequalities. Let's first take a look at the definition of a compound inequality. So a compound inequality is an inequality that is formed by joining two inequalities with either the word and or the word or. So everything we've learned previously about inequalities is still going to apply here, except now we're going to be joining two separate inequalities into one. So let's take a look at these two examples down here. This one is going to be a compound inequality connected with the word and. So our example is 2 is less than or equal to x, and x is less than 5. You can also arrange it in this descending order right here, where you start with the smaller value and then write its sign or symbol, in this case less than or equal to, your variable in the middle, and then lastly the greater number, in this case 5. So that's how they got these two different inequalities. However, they represent the same thing. So you would still plot the points the same way as you would a normal inequality. We have less than or equal to for 2, so that would be a closed circle. For less than, that would be an open circle. So plot your points at 2 and 5. And then, since a compound inequality with and consists of numbers that are solutions of both inequalities, you would actually connect those 2 points with a line rather than drawing your normal arrows that would point in a certain direction. As for compound inequalities with the word or, those will only consist of solutions of at least one of the inequalities. So for example, you have y is less than or equal to -2, or y is greater than 1. Go ahead and plot these on your number line as you would a normal inequality. So this would be a closed circle at -2. And since your variable is on the left, you can point your arrow to the left as well. As for y is greater than 1, that would be an open circle. And since your variable is on the left, you can go ahead and point it to the right. Now notice here that rather than connecting to the 2 points, they're simply just graphing the inequalities as they are on the number line. So any compound inequality joined with the word and, the points will connect, and a compound inequality joined by the word or will just be graphed as a normal inequality. Let's take a look at this first example. We're given a sentence and we're supposed to process this into an inequality. A number x is greater than -8 and less than or equal to 4. Recall that a compound inequality is going to be made up of 2 separate inequalities and joined by either and or. So first, look for your first inequality. That'd be x is greater than -8. Then go ahead and write that as an inequality. That'd be x is greater than -8. Then find your connecting word. That'd be and in this case. So write down and then finally look for your last inequality, which is less than or equal to 4. So this would still use the same variable since x is greater than -8 and less than or equal to 4. So you can just express it as x is less than or equal to 4. As shown in the previous slide, you can also write this in descending order. So first put your smaller value, that would be -8. And you can see that -8 has a greater than symbol here. However, the less than is pointing to -8. Then go ahead and have x in the middle. Then finally put your larger value on the right, which would be 4. Either way you can express it, it will still represent the same thing. Let's go ahead and graph this. So now that we've made an inequality, we can go ahead and graph it. First, draw an open circle at -8, since this is greater than. And then draw a closed circle at +4, since this is less than or equal to. And since we identified that our connecting word is and, you can go ahead and simply connect the two dots to make your graph. Let's look at this next example. We have a number y is at most 0 or at least 7. Once again, first look for your first inequality. So that would be y is at most 0. Note that down as a inequality. At most will represent less than or equal to. And then find your connecting word, in this case, or. Then find your last inequality, which would be y is at least 7. At least would represent greater than or equal to. Now that you have your inequality written, we see that we have a compound inequality joined by the word or. So first, draw a closed circle at 0. And then draw a closed circle at 7 just to plot down your values. Now that you've done that, you can go ahead and draw your lines. Since this is a compound inequality with the word or, we're going to have two different graphs. First, make sure that your variable is on the left before you draw your arrow in the same direction as the symbol. So I'm just going to graph this in the standard way we learned for inequalities. So y is less than or equal to 0 points to the left. And then y is greater than or equal to 7 points to the right. And that is how your inequality will look like. Here are a few examples for you to try on your own. So pause the video and unpause when you're ready. First, we have a number x is less than 2 or greater than 5. We're going to make this into an inequality. So first, I'm going to identify my inequalities. That'd be x is less than 2. Then find my joining word, which would be or. And then my second inequality would be greater than 5. So it would be x is less than 2 or x is greater than 5. And our inequality would look like this. Now that we have our inequality, let's go ahead and draw a number line. Since we have a less than symbol, this is going to be open at 2. And this is greater than, so it will also be an open point at +5. Then, since this is an inequality with the word or, we're going to have two different graphs. So graph these as you would a normal inequality for each. So x is less than 2, x is on the left, so draw your graph in the same direction as the inequality symbol, but just to the left. X is on the left for x is greater than 5, 2. So you can go ahead and draw your arrow in the same direction as greater than, which is pointing to the right. Here is our second one. We have a number y is more than -4 and less than or equal to 3. I'm going to identify my inequalities. So we have y is more than -4. Our adjoining word in this case is and. And then my second inequality would be less than or equal to 3. Now I can process this into an inequality. So y is more than -4. That represents y is greater than -4. And it is also less than or equal to 3. So those are my two inequalities. Once again, you can express it as a in this form with the smaller number on the left then the inequality symbol used, the variable in the middle, and then finally the other inequality symbol with the greater value on the right. Again, it's still the same inequality, just in a different form. Now we can go ahead and graph this. Since this is an inequality with the word and, we know we're going to connect the 2 points. So for y is greater than -4, that will be an open point at -4. And then y is less than or equal to 3, that will be a closed point at 3. Now, I just wanted you to notice that if you were to graph this just as it is, like as normal inequalities, y is greater than -4 would point to the right, and y is less than or equal to 3 would point to the left. So you see here that they kind of intersect one another, and that would kind of give you the connecting line that you have right here. Here are 2 more examples for us to try. We have a number n is greater than or equal to 6 and no more than 10. First, I'm going to identify my inequalities, which is n is greater than or equal to 6. Next is your connecting word, which is and. Then your second inequality, which is no more than 10. So n is going to be greater than or equal to 6, and n will be no more than is less than or equal to 10. So there are your 2 inequalities joined with the word and. Again, you can express it in this descending order. So first put your least value to the left. The way I like to look at it is whenever I see the lesser value, I like to flip it so that you can kind of visualize how it's going to be written. So B6 is less than or equal to n, and then n is less than or equal to 10. And that's where they get this form from. However, you can write it however you'd like. If you find this form easier, then that's totally fine. They just give you a few options. So let's go ahead and graph this on a number line. First, draw a closed circle at 6, since this is greater than or equal to. And then also draw a closed circle at 10, since this is less than or equal to. Since our compound inequality is joined by the word and, simply connect the 2 dots. And there is your graph. For our second example, we have a number z is less than or equal to -5. That is my first inequality, or, which is my adjoining word, more than 4. So z is going to be less than or equal to -5, or z is more than, which is also greater than 4. So here is our written inequality. We can now go ahead and graph this on a number line. So first, draw a closed point at -5. And then draw an open point at +4. Then since this is a compound inequality adjoined by the word or, you can go ahead and draw your lines in the 2 different directions. So just graph them as you would a standard inequality. Z is less than or equal to points to the left, then z is greater than will point to the right. So there are your 2 inequalities that represent this compound inequality. Now let's look at solving and graphing compound inequalities. For this example, we have -3 is less than -2x plus 1 is less than 9. As we've done in our previous lessons, our main goal is to isolate x. So we're going to need to do inverse operations to isolate our x and get our simplified inequality. So first, I'm going to undo any addition or subtraction as we did with multi-step inequalities. In this case, we're going to have to subtract it from all three sides. So this -3 and 9. 1 will cancel. And now you have -3 minus 1, which would be -4 is less than -2x is less than 8. And finally, go ahead and undo your multiplication, which is -2, by dividing everything by -2. -2 here will cancel out. Then you have -4 divided by -2 is 2. And since you are dividing by a negative number, always remember to switch your signs. So all of this is going to be switched to greater than. So +2 is greater than x is greater than -4. And there is your final inequality, which you can now graph. Remember that whenever you have this form where it's all connected in one inequality, it's going to represent a compound inequality joined by the word and. So you can rearrange this as you normally would into descending order. So that would be -4 is less than x is less than 2. Now you have your number line. First, plot an open circle at -4 and also an open circle at +2. Will look like that. And since this is a compound inequality joined by the word and, simply connect the 2 points for your graph. And there is your final graph. Now we have 3x minus 5 is less than -8, or 2x minus 1 is greater than or equal to 5. So the way we're going to solve this is we're just going to go ahead and solve 3x minus 5 is less than 8 as one inequality, and then 2x minus 1 is greater than or equal to 5 as another inequality. So carry out your standard operations. You would first undo subtraction, so that would be +5 on both sides. 5 would cancel, and you have 3x is less than -3, and you can undo multiplication by dividing both sides by 3. Now you have x is less than -1. Do the same for your other inequality. First, undo subtraction by adding 1 to both sides. That would give you 2x is greater than or equal to 6. And now undo multiplication by dividing both sides by 2. I give you your final inequality of x is greater than or equal to 3. Now that both of your inequalities have been isolated for x, you can go ahead and graph these on a number line. So since this is a compound inequality adjoined by the word or, first graph a open circle at -1 and a closed circle at 3. You can also just graph these as you would a normal inequality. So x is less than -1 would be pointing to the left, and then a closed circle and +3, and the graph would be pointing to the right. Here are 2 more examples for us to try. The first one is -1 is less than or equal to 2 minus 3x is less than 14. Our goal is to isolate x from this expression right here. So I'm going to use the same process that I used for multi-step inequalities by first undoing any addition or subtraction. So I'm going to do that by subtracting 2 from all my values. That would be -3 is less than or equal to -3x is less than 12. Now that I've undone any addition or subtraction, I can go ahead and undo multiplication by dividing all sides by -3. Now, since you are dividing by a negative number, make sure to flip your signs. So you would get -3 divided by -3, which is 1. Flip less than or equal to greater than or equal to. Then you're left with x, and then flip less than to greater than 12 divided by -3, which is -4. Notice here how you're not in order since your lesser value is on the right. Simply just flip it over. So that would be -4 is less than x is less than or equal to 1. And there is your final inequality that you can now graph. So here is the inequality. You would graph an open circle at -4. Since this would technically be x is greater than -4 and x is less than or equal to 1. You can also rewrite it as this if you're more comfortable graphing it that way. Then also draw a solid circle at +1. Since this is a compound inequality adjoined by the word and, simply connect the 2 points. Let's look at our second example. We have 4x plus 11 is less than or equal to 3, or 2x minus 8 is greater than -6. So first, just solve your two inequalities for x. I'm going to undo my addition by subtracting 11 from both sides. This is just like multi-step inequalities. 3 minus 11 would be -8. Then undo multiplication by dividing both sides by 4. You get x is less than or equal to -2. We're going to do that for the same thing for the other inequality. So add 8 to both sides to undo subtraction. -6 plus 8 would be +2. Then you had 2x is greater than 2. Divide both sides by 2. That would be x is greater than 1. So your final inequality is x is less than or equal to -2, or x is greater than 1. You can graph this on your number line. So first, graph a solid point at -2, then an open point at +1. Then graph these as you would normal inequalities. So x is less than or equal to -2. Variable is on the left, so point in the same direction as the inequality symbol. Same for x is greater than 1. That is the end of today's video. As always, all information regarding lesson requests, tutoring, and additional practice will be linked down below in the description box. If you ever have any general questions about what we learned in the lessons, feel free to contact me at my email below. Thank you so much for watching, and I hope to see you in the next video.